Okay, try this problem out, see what you can figure out. I'm going to solve it now. So we have a non-homogeneous second order differential equation, and we have some points along with it that we could probably use to help us find our full solution. So the first thing you want to do when you're dealing with this kind of problem is you want to find your general solution. Now the general solution is done by setting this value here to 0. The value that is not a part of your derivatives and has no independent or dependent variables. Okay, so we'll set this 10 to 0. Next thing you want to do in this instance is change it into the quadratic form, because we can do that with our derivatives. We're going to solve this to find our general solution. Now I'm going to use the quadratic equation. So negative b is negative 8 plus or minus the square root of 8 squared, which is 64. Oh, wait. We don't need to do that. Sorry. We can just factor this. This factors into r plus 4 squared. These two 4's will add to make that r there. They will multiply to make this 16. So we will get r is equal to 4 twice, meaning both of your roots of r are going to be equal to 4. Another way you could do that actually is by using the quadratic equation, and you will get to this point and you'll find 8 squared is 64, and then it'll be 4ac, 4 times 1 times 16 minus 64. You will find that they're equal and you'll be given the same solution. Okay? But in this case, I know, and many of you just may memorize, that when you have two equal roots, you will have the solution that looks like this. E to the 4t plus c2t e to the 4t. So it's almost like the same as a normal non-imaginary solution, except for you add a t. Okay? So this is the solution to the general solution to our equation. Let me take a sip of water real quick. So what does this tell us? Well, it tells us the general solution, but we have more information than that. We have x equal to 1 at t equal to 0. So we can use that to learn something about this equation. So let's do that. I'll plug in x equals 1 at t is equal to 0. So t is equal to 0, so this is a 0 here, plus c2, 0, e to the 4t. This will be a 1. This whole thing will turn to 0. So now we know c1 is equal to 1. Okay? But what about c2? How are we going to figure out c2? We have this now. I'll plug in the 1 for c1, e4t, plus c2t, e to the 4t. Well, that still doesn't really help us for c2 because we have this x that's unknown. We have this t that's unknown. We have c2. So unless we have values for x and t, let's see. Well, dx dt equals 0 at t equals to 0. Okay, well, we can do that because we already did this one. This isn't going to help us with finding c2 because c2 will get eliminated in that instance. You see what I'm saying? So in blue, we're going to go ahead and find dx dt, and then we're going to see if these values, we'll plug in the values and see if they help. So let's find dx dt. E to the 4t, that'll be 4e to the 4t. This one we'll have to break up with the product rule. So this will be c2 e to the 4t plus c2t plus 4 c2 e to the 4t. Oh shit, still got the t. E to the 4t, okay? Yeah. Alright, so now we have our dx dt. Let's see what these terms are again. So dx dt equals 0 at t equals 0. Okay, so dx dt is 0 at t is equal to 0. So we plug in a 0 there, plus c2e to the 0, plus 4c2 0 e to the 0. So this whole thing will cancel by this 0 here. This e will turn into a 1, and this e will turn into a 1. So now we have 0 equals 4 plus c2. So now we see that c2 is equal to negative 4. Okay. So good, we're making progress. And now I'm going to plug in c2 back into our regular form. X equals e to the 4t minus 4t e to the 4t. Okay, well now you're looking pretty good because you don't have any c values. The only thing left to do is check to see if your equation will work for the problem. So we plug it back into this original equation. We have our dx dt, we have our x. We don't have this d2x dt, so let's do that real quick. So dx dt, I'm going to do this real quick, e to the 4t minus 4e4t minus 16t e to the 4t. Okay. That's dx dt. d2x dt is equal to 16e to the 4t minus 16e to the 4t. So these would cancel, right? Minus 64 te4t minus 16e to the 4t. Okay, so now we have all these values. We could plug them in and check if they're equal to 10, right? And you could do that. That's going to be a bit of a pain in the ass, though, right? Because you saw how big those equations are. Excuse me. You saw how big those equations are. So the one thing you could do instead of doing that is just kind of notice that, look, all your values are ending up with e to the 4t's, e to the 4t's, t e to the 4t. But then when you go up to the right here, you just have this 10, right? So that's a problem because if all of your variables, if all of your terms, rather, have e to the 4t, then this would have some sort of e to the 4t with it. You see what I'm saying? So that means you need to plug in some sort of constant. And the best place to plug that in would be on the x, because on the x, as soon as you take the derivative, you won't have that constant anymore. So what would equal 10 that's multiplied by 16? That'll give us this value of 10 that we're looking for. So we will do 16 times some constant equals 10. C over 10 over 16. C equals, what is that, 5 over 4? Yeah. Wait, no. Divided by 2, 5 over 8, 5/8. So now we have this value here, which is 5/8. I know it's a little weird to do it like that, but that's really the only way to go about getting your constant in there. So now when we take this derivative down here, you would have a plus 0 there. It would not contribute to the derivatives. So the only place you would see that in the original equation is in this x. It would give us our 10. The rest of the equation's all smooth. There you go. Thank you. So, well, I guess I'll recap. This is your answer when you plug in the shit. You got to plug in your C2 values. What was it? 1 and negative 4? Negative 4. So that would be your answer. It's a bit of a messy problem. Just work through it. This is a pretty reasonable question to be given on the FE.